Different sources of energy for the power generation. So the advantage of electrical power is we can generate the power from so many different sources. So not only a single source, we are able to generate from various sources, different sources. So that is one of the advantage. Even though we are majorly depending on the thermal power, that is the major advantage. So we have been discussing about renewable energy, non-renewable energy, and in our previous class we have discussed about the tidal energy and the comparison. So now today we'll discuss about the wave energy. This is also hydro dependent on the hydropower. So hydro means water. So this water energy we are using to generate the electricity. So in our previous classes we have discussed about the tidal energy. So many people are familiar about tidal energy and very less are familiar about the wave energy. See, both, if I am saying hydro, so hydropower means in olden days we used to have hydropower from the dams. So we used to construct the dams on the rivers, and we used to increase the head, and we used to store more water, and then we used to develop the power, produce the power. So in recent days, especially in renewable energy, in non-conventional energy, so with the help of the hydro only, we are not depending on the river, we are depending on the ocean. So which is available throughout the year. So normally the hydropower based on a dam is not available throughout the year. So if you observe countries like India, sometime, so especially in South India, during summer the water is less. In North India near to Himalayas during winter, due to the freezing conditions, the water is not available. So to come out of this type of problems, so we went for the non-renewable sources, we went for the renewable energy sources, and that is non-conventional sources. So here, so the ocean is the place where the water is available throughout the year, and we have the clear record about the waves, and we will have the track record. So on a particular year, on a particular month, what could be the height of the tides or the waves. So here the tidal energy a little bit varies from the wave energy. It little bit varies from the wave energy. So tidal energy, we are nearer to the land when you compare with the wave energy. So wave energy means somewhat we are going into the sea, and the source is same for both the energies. So here in the diagram you can observe. So here we are converting the surge of the wave into the hydropower. We are converting the surge of the wave into the hydropower. So at starting we are having fixed surge converter. Okay. So here it is fixed here. So whenever the impulse is created on this plate, so that mechanical energy is converted into hydropower. And a little bit deeper, we have installed different type of converters, floating surge converters. You can observe here. So these are the floating surge converters. So whenever the wave comes, there will be ups and downs. So this expansion and ups and downs on the wave are converted into the. So whenever wave is level is high, it is going up, and when level is low, it is going down. So it happens actually. You can also observe when a boat, so it will be fluctuating up and down. So similarly, that surge, that up and down. So the floating surge converter is able to capture that strength, and that will convert into the mechanical energy is again converted to the electrical energy. And we will be having a surface attenuator. So we will be having an idea. So where the wave is, what is the height of the wave. So this is how the functioning happens in a wave energy plant. I want to say, but it is okay if it is such good. And also another thing is the dealing with river water. It is a different kind of task and different kind of handling the situation, and dealing with the motion is different kind. So there you need to increase the height, you need to construct. So there also you need to search for a good place which is having very large reservoir capacity. Okay, collection area, high head, all these things. So here also, but there you are not dealing with the salt water. And this much of sand is also not there. And that is a totally different situation. When you come to the tidal energy or wave energy, uh, here the major problem is you have to deal with the salt water. So dealing with salt water is not easy. So even the cement, so after invention of the cement only, that is a milestone in the construction field, because it gets stronger with water. So in olden days, whatever the construction will get weak with the water, but it is a reverse case. So after that invention, the perception has totally changed. And but even that will not work properly. That is very weak in the hands of the salt water. So the construction, even the material, even the metals will deteriorate very fastly in the salt water. So this is a, and also the impact. So imagine the case of cyclones or very high tide. So impact they can create is very high, and it can damage the equipment, damage the construction. So that is a separate thing. You have to take into concern. You have to handle it with care. And so coming to the next thing, so we'll see. So both the tidal energy and wave energy are based on the hydro, that is especially about the ocean, sea, So the wave energy is a form of renewable energy. So renewable energy. So the search for new type of energy sources, the search for renewable sources, the search for non-conventional sources led the way to here, the tidal energy or wave energy. And renewable energy that captures the kinetic and potential energy of ocean waves to generate electricity. So if you observe the wave, so there you can have both kinetic energy and potential energy. So the fixed surge converter, it purely works on the kinetic energy. If you come to the floating surge, it is majorly dominating the potential energy because ups and downs. So here the movement of the water towards the shore, here the movement of the water vertically. So here the movement of the wave horizontally, here the movement of the wave vertically. So the wave consists of both types. So for that we need to capture both the energies of the wave. So we are having different converters, different energy surge converters. Okay, it is promising, it is clean because it is available all over the year. So sea is available. Sea is more than the land itself. But the thing is, we have to find the best place for that. So it is no doubt it is a vast energy. So waves are created due to the gravitational force of the moon, sun, earth. Okay, that will be there for entire the year. And during the time of the cyclones, we have to take much care. So the wave energy converters are devices designed to capture wave motion and convert it into the useful energy, electrical energy. Here our main motto is electrical energy. So then, we are having different types come into picture. Different types of equipment come into picture because it is a combination of different energies. So we will be trying in a trial and error method, which will be better. So the first thing is point absorbers. So these are floating buoys that move with waves driving hydraulic pumps on generators. Okay. So point absorbers are one type of the category which are helpful in converting that wave energy into electrical energy. So they will drive the hydraulic pumps and the generators, that is point absorbers. So these are floating type. Next thing is oscillating. So these are oscillating water columns. So partially they are not fully placed inside the ocean. They are partially submerged, such as where wave action compresses air driving the turbines. So these are partially submerged and the wave action compresses air driving the surges. So based on the compression mechanism, these are going to convert the wave energy into the electrical energy. Next, another type of wave converting equipment is attenuator. So this is another type. These are long. These are multi-segment floating devices that flex with waves. Okay, and generating the power. Example, Belamis wave energy converter. So this is another option we are having. And another type is overtopping device. So this is a reservoir filled with incoming waves and wave is released through the turbines. This is a reservoir type of device. Next thing is oscillating wave surge converter. So this is what we have observed in our diagram. Okay. So this oscillating wave surge converter, paddle-like device that move, it will be like a paddle, back and forth with wave surges. So wave is moving back and forth, up and down. So it is not clear-cut movement, not going in single direction. Sometimes it will move front, it will move back, it will move high, it will move low. Okay. So for that, different options we are having, and based on the type of the waves created in a particular shore, particular site, we can have any of these 5 things. So point absorbers, oscillating water columns, attenuators, overtopping devices, oscillating wave surge converters. So here, how the process is happening. So the wave motion, so that creates the mechanical movement. Okay, it is a mechanical movement. So based on this mechanical, what are the things working are buoys, paddles, and air pressure. And next thing is mechanical energy. So drives a generator. So after we are we are able to take that mechanical energy. This is converted into generator, that is hydraulic, pneumatic, and direct electrical. Or sometimes we can directly convert to electrical. So after this mechanical energy again is converted to electrical energy, transmitted to shore via underwater cables. You can observe the underwater cables. See, you can see underwater cables we are having. So this is the scenario. This is the type of work. And what are the advantages? So advantages are, these are abundant, these are renewable. So waves are generated by wind and tides. Okay. So tides are created by gravitational force and wind. Wind with the help of due to the sun, making them a continuous energy source. It is a continuous energy source, especially at the shore. You can observe. So if you move much more deep into sea, that is a different case. Next, low carbon footprint. So minimal greenhouse gas emission compared to fossil fuels. So nowadays, whatever may be generally the non-conventional sources are almost greenhouse, almost green energy or renewable energy. Okay. So here we are having minimal gas emission, maybe during its process of making. Next, high energy density, which is important in our because we need to convert that energy into the electrical energy density. So waves carry more energy than wind or solar. So this is same for the tidal also. Next, predictable. Wave patterns are more consistent than wind or solar. So if you are having a track record of 12 years or 10 years, when you compare with the wind or solar, the wind it will not repeat exactly. A solar also, because the clouds may disturb that. But about the tides, we can predict almost more predictable than this wind and solar. So we can have offshore potential, onshore and offshore. So that is offshore reduces land use conflicts. So in the land means land is very less and it may be disturbing. we are going into the sea. Okay. So this is offshore option is there. Is actually we are going inside, so it is offshore. Okay. So what are the challenges? So it is same for the other renewable sources, that is the high initial cost. So expensive infrastructure and installation, because this is a different case. You have to deal with the salt water, you have to deal with so much of the sand, you have to deal with cyclones, very high superpower, that is ocean. Yeah. So that's why it is high initial cost. And also it is harsh marine environment. The environment is very harsh. So this much of impulse, this much of harsh environment we have to withstand. That is salt water corrosion is there, storms, biofouling, marine growth. Marine growth will be there. That is also another problem. And connecting this to the grid is another very big typical thing. So transmitting power from offshore to the land can be difficult. It is difficult actually. So if the city is there at the sea, it is good. All the cities will not be at the seas. So next, environmental impact also it is creating, that is potential effects on the marine ecosystem and coastal erosion. So these are the challenges. So then what will be the future? What is now and what is the future of this? What could happen in the future? So the leading countries here are where India is there: UK, Portugal, Australia, and US. So India being a peninsula, of course not an island. India being a peninsula, having so much of coastal area, we have not focused on this wave energy. Okay, the leading countries are UK, Portugal, Australia, and US. They are investing more on the wave projects. Next thing is emerging technologies, that is hybrid systems. So future, that is hybrid wave and wind. So for same machine, we will be having wave energy, wind energy, like this, solar energy. Okay, for a single pole, nowadays it is possible. And advanced materials for durability. Durability is needed, and the technology is doing it for. And next thing is government support, incentives are given by the European Marine Energy Center. So for any renewable energy, because the initial cost is, installation cost is more, the government has to provide subsidy or it has to give loan. And governments are also encouraging that. And what are the noble projects? Mutrika Wave Power Plant, that is Spain. Okay, Spain is not a peninsula, not an island, but still it is focusing. But a majority of its country is a small country, so it is having a large coastal area. The first commercial wave energy plant happened in Spain. And also Australia, a submerged buoy system. So here the submerged buoy system is installed here, providing power and desalination. So they are doing desalination also here. And UK, test site for wave energy devices. So UK we are having the test sites. And also wave energy has immense potential as, okay, it is, since it is the ocean, it will be having immense potential and it is reliable, so it is available throughout the year. and it is also sustainable. It is also clean, so no pollution is generated. So while technology and economic challenges remain, the advancements in the engineering and policy support could make it key in the future. So in the future, it will make it key because the demand is increasing day by day. So today we have discussed about the wave energy. So only the thing what we are doing is we are capturing the potential energy and kinetic energy of wave and making it the help of the device into a mechanical energy, and again that is converted into electrical energy, sometimes maybe directly. So there are different types of equipment to convert this energy. So this is a buoy type, this is floating sets type, and this is fixed. This is one of the example, and there are different things. So that is point absorbers, oscillating water columns, attenuators, overtopping device, oscillating wave surge converters. So how it is happening? So that is wave energy into mechanical energy and mechanical energy into the electrical energy. And advantages are so many advantages are it is renewable, abundant, low carbon, high energy density, predictable, offshore, and also challenges are high initial cost and harsh marine environment. So you can imagine how disturbing the ocean can be. And connecting to the grid may be difficult, and also having environmental impact. It may be disturbing the marine sources there. And what are the best sites in UK? Where UK, Portugal, all these things are investing much on these projects. And emerging technologies, we are having hybrid, so which is mixed with the solar, wind, and this wave energy. And government is supporting for these things. And novel projects are first thing at Spain, and a good thing at the Cito, Australia, along with desalination. And UK is there, Wave Hub is there, where they will test this equipment. And finally, we can conclude it is more reliable, it is economical, it is clean, and it is sustainable. And thank you.
Like, share, and subscribe. Hit the bell icon for more updates.